Hi, today I'll show you how to design a mission from a low Earth parking orbit to lunar orbit. This actually requires some trial and error to get the timing correct. However, we've done that for you. Start by clicking on the New button. Then set the simulation start time to December 18th, 2025 at 9 a.m. I'll wait while you type that in. OK, click outside the Date Time tool to close it. Next, check the Synchronize Epoch to Start Time checkbox. Now set the default simulation time span to 4 days and 12 hours, and then press the Tab key before recalculating the orbit. It takes about 4 days to reach the Moon from the Earth, using an elliptical transfer orbit. For this example, we assume that the Earth has no atmosphere at our parking orbit altitude, but does have a bulge. We also assume that both lunar and solar gravity are acting on the satellite. Obviously, we need lunar gravity for the satellite to orbit the Moon. Next, verify that the Moon orbit line checkbox is checked and the satellite orbit steps checkbox is not checked. Also, set the spacecraft size to 18. Click on the Add Satellite button to see the Set Initial Parameters dialog. In this dialog, choose the Parking Orbit Insertion option. We assume that this satellite was launched from Brownsville, Texas, in an easterly direction. Since its latitude is nearly 26 degrees, the parking orbit will have an inclination equal to 26 degrees. In the Place Lookup text box, type Brownsville, Texas, press the Tab key, and then click on the Submit button. There should be one location found, therefore click on the Use button. Type 400 kilometers for the desired altitude, press the Tab key, type 26 for the desired inclination in degrees, and then press the Tab key again. Finally, click on the Set Parameters and Recalculate Orbit button. You should now see the low Earth parking orbit as it drifts due to the Earth's bulge over the 4 days. Now, rotate the camera around the Earth until you see the satellite at the center of the Earth. You should now also see the Moon's yellow orbit track. Turn off Show Delta V and change the satellite image to a red ball. Click on the Go to End of Simulation button and then zoom the camera out so the Earth is small. Next, move the camera so the Earth is viewed directly over the Moon. We do this because we want the Moon to be at apogee of our elliptical transfer orbit, and this will be behind the Earth when we enter the transfer orbit, at our side of the Earth. Now, zoom the camera back in. Next, use the Go to Time button to place the satellite at the simulation time, 1 hour, 32 minutes, and 0 seconds. You should now see the satellite approximately centered on the Earth. Again, this is on the opposite side of the Earth, relative to the Moon at the end of the mission. OK, go to the Timed Events group box and click on the Add Delta V button, so you can use a rocket burn at the current simulation time to enter the Hohmann transfer orbit. When the Delta V calculator dialog box opens, type 410 million meters in the Apogee-Perigee text box and then press the Tab key. Next, click on the Set Required Apogee for Elliptical Orbit button. Finally, click on the Use and Recalculate button to return to the main window. Now zoom out so the Earth is small, and then move the camera around to the Moon side of the Earth. Zoom out until you can also see the Moon. Note that the satellite is being pulled toward the Moon and will slingshot off the Moon if we don't do an orbit insertion burn. It is sometimes challenging to find a suitable point in the trajectory to do this burn. You can practice this later, but now we have chosen one for you. Place the satellite at simulation time 3 days, 20 hours, 40 minutes, and 20 seconds. Now click on the Add Delta V button to open the Delta V calculator dialog. In this dialog, click on the Do Manually button. The dialog will close, and you'll see a delta V in the left side control panel with no values listed for the 3 axes. You need to enter these values yourself, and it could take some time to get the proper values for the lunar orbit you want. Use the 3 coordinate axes shown at the bottom of the window as guides for your trial and error guesses. You can also practice this later. For now, use 400 for the x-axis, 800 for the y-axis, and 100 for the z-axis, pressing the Tab key between each entry. Finally, increase the simulation time to 8 days and recalculate the orbit. Your satellite is now in lunar orbit. As you can see, there is much trial and error associated with designing this mission. Just remember that there are few windows in time where you can reach the moon from this parking orbit. Theoretically, there should be 2 for each lunar orbit around Earth, or 1 about every 14 days. And each of these windows will have its own width in minutes or hours. The width of this window will be a function of how close the inclination of the initial parking orbit is to the inclination of the moon's orbit. Thank you for watching this video. We hope you enjoyed it. If you did, please give it a like and consider subscribing to the channel. We will be producing new content in the future, so it is also worth hitting the notification bell. We need your feedback, so please leave a comment. Goodbye.